Geometric series. So remember, a series is when you're plussing the terms. We're finding the sum. And it's geometric, so we're multiplying by the same amount each time. All good? So it says a geometric series is the addition of successive terms of a geometric sequence. So just look at the top line. Sn is u1 plus u1r, because we times by r each time. Then u1 up times r squared, plus all the way to u1 times r to the n minus 1. Is everyone cool? Beautiful. Now, Sn equals, so now here's the thing, here's the formula. Ready? Sn is u1, the first term, times r to the n minus 1 over r minus 1. Now this is if technically what I've got here is wrong. I should have done the absolute value of r is bigger than 1. Can you type that in? Where the absolute value of r is bigger than 1. So r is 2, r is 3, r is even 1.5, r is negative 4, whatever. Find the sum of 2 plus 8 plus 32 plus ... so it's a series, up to 15 terms. Now, girls, from that, can you tell me what u1 is, r, or how to find r, or n? Okay, so u1 is 2. What's r? 4, and you could have found that by doing 8 divided by 2. What's n? It's the number of terms, which is 15. Is everyone okay so far? Now, girls, look at this r value. R is 4. Given, don't call it out. Give it that r is 4. Which formula would I use? 1 up here or 2 down here? What do you think? 1, because in this case, we've got this one. R is bigger than 1. So now let's try using this formula. I'm just going to write it down first just to make sure. Sn is u1 times r to the n minus 1 over r minus 1. So let's go from there. So n is 15, so that becomes s of 15 equals, what's u1 again? 2. Brackets, make sure you use your brackets. R to the n, how would I write that?
4 to the power of 15.
Beautiful. Minus
1.
over,
15.
sorry, 4 minus 1. And now just put that in your calculator.
1, 5, 8, 2, 7, 8, 8, 2.
Beautiful. Okay, that's 715,827,882. Makes sense that it's a big number because we're multiplying by 4 every time. Find a formula for Sn for the first n terms. N terms. Oh, we have to, I guess it's an expression involving n. Okay? Now, first of all, what can you tell me from the values we've been given? Just take a moment, just tell me anything. What are some of the things we're going to need? 6 is u1. Negative 3 is u2. This positive 3 on 2 is u3. Does that make sense now?
Yeah.
Negative 3 on 4 is u4. Is everyone cool?
Yeah.
So now that might help. What is u1? Beautiful. Take a moment. What is r now? Or can you tell me how you'd find it? Beautiful. Minus 3 over 6. And what should that simplify to? Negative a half. Which of these formulas, number 1 or number 2, should be used? Don't call it out. Number 2, because in this case, negative a half is definitely between negative 1 and 1. Like if you imagined it on a number line. Sn is u1. Was it? And now it's 1 minus r to the n over 1 minus r. All right, so let's put everything in. Can you help me out, please? 6.
1 minus negative a half to the power of n.
Now, girls, notice how I wrote it. I had to write negative a half all in brackets and then put it to the end. You know what? Actually, one thing at a time. But do you understand that? And if it were a calculator question where I knew n, I would put it in my calculator just like that too. Okay? And what does that become on the bottom?
1 minus negative a half.
Beautiful. I could have put negative a half in brackets. I'm just lazy and I don't there. Is everyone okay? Now, because they're asking for a formula for Sn, 6 outside of 1 minus negative a half to the n over 3 over 2. Because it becomes 1 plus a half, which is 3 on 2. I'm going to leave this as it is. How I can simplify that? 6 divided by 3 on 2 without using a calculator, just for fun. Beautiful. You can think of it as 12 on 3 first. And then, oops. Is everyone okay? Because, I'll just take a side note. 6 divided by 3 on 2 is 6 times 2 on 3. 6 2s are 12 divided by 3 is 4. Is that okay? So that's where I got the 12 on 3 one, and then it's finally 4. That could be expected of you in a paper 1. Find the sum of that. Is there anything you know out of the U1, the N, and the R just by looking at that? N is 20. That we know from just by looking at it. But, so N is 20. Let's write that down first. But now, let's just take a moment to expand it to see if the first few terms, and then we should be able to figure out everything else. Oops. Okay. When k is 1, what do you get? Negative 8. 4 times negative 2, which is negative 8. And it's a sum, so I put plus straight away. When k is 2, negative 2 squared is 4. 4 times 4 is 16. And let's do one more, because you know how we like to have 3 terms at least to see a series. When k is 3, what do we get? Negative 32, you're right. And then it's going to go plus ... Now that we've done that, what else can you tell me? We knew n is 20. What else can you tell me? U1 is beautiful. What's R? This negative 2 here that I'm timesing by each time, but if you're not sure, do 16 divided by negative 8, and that is negative 2. Is everyone cool? Beautiful. And now we're ready for the formula. Now, girls, which formula should I be using, though? The first, the one with r to the n minus 1. Beautiful. So, I'm just going to write down the formula first. U1, r to the n minus 1 over r minus 1. U1 is negative 8. R to the n, what should I write here? Minus 2. Brackets, yes. Squared? To the 20. Yeah, that's all right. It's up here, all the way up here. Minus 1 over? Beautiful. And now just put it in your calculator. What's nice is the negatives will cancel out. 2 million again.
796,000.
Beautiful. 200. Thank you so much. I'll just start of an infinite geometric series. So, now here's the absolute value thing, and I want to figure out why you don't know about that. But what this says is, it actually says if r is between negative 1 and 1, then r to the n approaches 0 as n approaches infinity. Now let me explain that. For instance, if r is a half between negative 1 and 1? Yeah, so we're on the right track. And let's say, instead of n approaching infinity, which is very abstract, let's say n is 999. In other words, a really, really big number. Making sense? Yeah. So, then, r to the power of n would be a half to the power of 999. Is everyone okay? Now, girls, wait a minute. 1 to the anything is just 1. Is everyone in agreement on that? So the numerator just stays 1. Then the bottom becomes 2 to the 999. Now, you can, if you want, I don't think you can even put it in your calculator, but think about it. 2 to the 999, which is 2 times 2 times 2 times 2, 999 times, is a pretty big number. And 1 divided by an extremely big number is going to be close to 0. It's going to be so small that it's practically 0. Does that make sense? So it's a bit abstract, but it's just understanding it. So if that approaches 0, then basically this part of the rule equals 0, so it kind of disappears. Does that make some sense? Think about it. Basically, we're assuming if n is approaching infinity, getting extremely big in the hundreds, thousands, whatever, then that r to the n is so small and insignificant, we no longer include it in the formula. So now, what does that all mean? So basically, this is the definition. An infinite sum or limiting sum is basically the sum of the infinite number of terms. And again, as if n is then approaching infinity, the r to the n is 0, or so close to 0 it's insignificant. Therefore, we now use this formula where r is between -1 and 1. Find the limiting sum of the series. I'm just going to make it up. 16 plus 4 plus 1 plus a quarter plus ... Tell me, what can you tell me from that information? U1 16, I agree. What else can you tell me? R is, no, 1 on 4, thank you. R is U2 over U1, 4 over 16, which is a quarter. Now, wait a minute. If R is a quarter, can I use limiting sum in this question? Do you understand, girls? Since this is less than 1, I can use limiting sum. I just want you to not take it for granted. I know, I understand the question asked you to do it anyway, but I just want you to understand it's because R is between 1 and -1 that we can do this. And because it's a limiting sum, that means n is approaching infinity. So girls, what's that formula? And I don't do it in terms of n, I just do S. So S equals, what's the original formula? Over? Beautiful, that's all I have to do. So can you help me out? What's U1 again?
16.
Over?
1 minus a quarter.
Yes, there we go. And I'm fine for you to put it in your 21.
0.33.
Yeah, 3 recurring, which is annoying, but anyway. Write 0.8 recurring as a rational number using series. Let me explain what I mean by this. Girls, what's 0.8 recurring as a longer decimal? Like,
0.8.
beautiful. Now, I'm separating this huge decimal into 0.8 plus 0.08 plus 0.008 plus 0.0008 plus ... So in other words, this 8 is there, this 8 is there, this 8 is there, this 8 is there. Now we're going to write them as fractions to make this easier. This becomes 8 on 10, and then 8 on, then 8 on, then, sorry, is everyone okay? Plus, and does it keep going?
Yeah.
Is this an infinite sum? Why? It is, why? It's a recurring decimal that goes on forever. Therefore, these fractions are literally going to go on forever. Therefore, it's an infinite sum. Therefore, I can use the U1 over 1 minus R formula. What's U1? Yep. What is R? And if you don't know it, it's okay. We can work it out. A tenth. Now, girls, tell me this. Is the numerator changing each time? So you're timesing the numerator by 1 because you don't want it to change. What's the denominator doing? Adding a 0 and therefore timesing by 10, therefore altogether it's 1 on 10. Are we ready to put in the formula? So I'm just going to write down the formula u1 over 1 minus r. So it is 8 on 10 over 1 minus 1 on 10. It is. Did anyone else get that? Fantastic, and it's good to push ourselves. Now, girls, let me explain why. The denominator is 8 on 10. What does the numerator simplify to? 1 minus 1 on 10 is? 9 on 10. But wait a minute. If I just times the top and bottom by 10, cancel, 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 I just left with 8 on 9. I want to highlight something. Using series. Now, some of you may know 0.8 recurring is 8 on 9, but they've told you to use series, therefore you have to show this. You can't just write 8 on 9. You may not get any marks at all because you're not using the method they're telling you to use. So I just want to point that out. The sum of the first 3 terms of a convergent series. Ooh, convergent. That means, I'm going to highlight that word. Convergent means all the values converge to a small number, or in other words, it means r is less than 1. So like we're timesing by it and making it smaller and smaller and smaller and smaller. This word means it's geometric and r is less than 1. Consider this series, 10, 5, 1, a fifth, a 25th, plus dot, dot, dot. What's happening to each of those terms? They're getting times by a fifth, and they're getting smaller and smaller. They're converging to a finite number. They're converging to like a small number. And the sum of them is converging to a small number, as opposed to if they were increasing, or the sum would just approach infinity. Is that okay? It also means it has a limiting sum. So convergent means it has a limiting sum. That's how you should remember that. So that tells us we are going to use this at some point. Oops, 1 minus r, apologize. The sum of the first 3 terms is 39. So in other words, u1 plus u2 plus is beautiful. And the sum of the series is 41. And this one here equals 41 because, girls, look at that sentence. The sum of the series. They haven't told me how many terms. Therefore, they must have meant the whole infinite series. Does that make sense? Beautiful. Okay, so all of that is 41. Find the first and common ratio, term and common ratio, sorry. Now, if I can get both those in terms of u1 and r, I can do this and I can solve them simultaneously. One thing at a time though. Let's focus on this here. Okay? u1 is just u1, no problem. What's u2 in terms of r and u1? Yes? Beautiful, u1 times r. Is that correct? What's u3 in terms of u1 and r? Beautiful, you just times by another r. That's all. All of that is 39. Okay, I don't feel like I can do a lot with that yet. Let's consider the other equation, this one here. Write this out again. u1 over 1 minus r is 41. Not loving a fraction. How could I maybe work out u1 in terms of r from that? Beautiful, bring that over in times. u1 equals 41 times 1 minus r. So u1 is 41 minus 41. Okay, so can you see maybe what I could do now? Put u1 into there. I get 41 minus 41r. And then u1 times r, I get 41 minus 41r. Oops, sorry. Times another r. Plus u1 times r squared. 41 minus 41r r squared equals 39. This becomes 41 minus 41r plus, what happens when you expand that bracket there? Oh, this actually might work out. 41r minus, 41r squared. And then what over here? Yep. Beautiful. Equals 39. Now, I thought at first we were going to have to use like polyroots or something to solve this thing. But what can we cancel?
Less 41r cancels with the plus 41r.
Beautiful. What else can we cancel?
41r squared cancels with the plus 41r.
Exactly. So let's rewrite it. It becomes 41 minus 41r cubed equals 39. Any thoughts?
Minus 41.
Minus 41 on both sides. I think you get negative 2.
Yeah.
The negatives then cancel out. So what does r cubed equal?
2 on 41.
Yep. And so what do I do to find r? Cube root. Now usually in the IB they want a decimal in the end in this kind of thing. So can anyone tell me what that is to at least 3 significant figures, please?
0.365.
Beautiful, thank you. Now, we found r. Yay. What else did we need to find?
You want to solve it back.
Yes, so what was that formula for U1? Hopefully you can see it on your sheet.
41 minus 41r.
Yes. Which equals 41. 41 minus 41 times 0.365. And what does that all become? To at least 3 significant figures.
26.305.
26.3035. 0.035. Beautiful, and that's it. Back when we had this ugly polynomial, if things didn't simplify, hopefully it was paper 2 and we could use polyroots.